Hi, today in this session I shall be showing you how to develop ARDL model or bound test using EViews 10. We suppose that we have time series data and data should be stationary at level or at phase difference or mixture, but not at 2. In this case, we can use ARDL model and to see whether there is a short run and long run associationship between the variable in the model. And here our model. ARDL model, as you can see, this is the specification of the model. This is GDP in current time, and its summation TI, which is more than variable. We can use it. This is a formula. B1 D GDP lag 1, B2 or beta 2 D export lag 1, beta 3 D import lag 1, and here GDP lag 1, export lag 1, import lag 1. What is the difference here? The short run include difference, as you can see it. Difference GDP lag 1 become independent variable as a lag, and difference export, difference import. While the long run without difference, only the lag, GDP lag 1, export lag 1, import lag 1, which is the same variable here. You can see it here, D GDP lag 1, GDP lag 1, D export lag 1, export lag 1, D, which is difference import lag 1, import lag 1 with the error term or the disturbance term. And this is, we call it long run, and this is short run. As you can see, this is the long run, GDP, and we'll include this part here. As you can see, this is the long run, and the short run here. I put it in separate, just subdivided with the error term, of course. And the error correction model based on a Granger causality model. How we construct the error correction model? The error correction term, as you can see, this is the long run equation, which is here. Long run equation. From this equation, we find the residual of this long run equation, and then we take a lag and we consider it as ECT lag 1. So ECT lag 1, we get it from the long run equation and as a residual, and then we put it as a lag 1. Then here you can see that D GDP lag 1, D export lag 1, D import lag 1, and this is the error term for ECT error term, where we can say ZT minus 1 or ECT minus 1 with the error term. So this one, the short run, plus the error term, Z lag 1. So always short run include the difference, like difference GDP lag 1, and the long run without difference, only the lag. Here we have some steps to estimate ARDL model using EViews 10 as follows. Find the lag using in the analysis, lag structure criteria. Test stationarity, unit root, using the lags created in part 1 or step 1. If unit root stationary at level, we can simply use simple regression. If unit root stationary at first difference, we can use the configuration. But if the unit root stationary at mixture level and first difference, we can use or apply the ARDL model. But in any one of these, the test of the stationarity, we are going to test for 3 options: at level with constant, at level with constant and trend, at level with none. Then the same thing for each variable, then the same thing we use it for the first difference at level, first difference with constant, as we can see it when we go to EViews, and then we apply it. So when we apply ARDL bond test model, we test for configuration and long run form, which is long run and short run, and then test for the F statistic. When there is a configuration, we apply error correction model. So if there is no configuration, we apply VAR model. So an error correction model can be used with one endogenous variable, which is dependent variable, and the vector error correction model can be used with more than one endogenous variable, and then we test after we did the ARDL model, error correction model, and then we have to go for diagnostic test. The model should be free from serial correlation or autocorrelation. We apply Bruch-Godfrey serial correlation LM test. The second, the model should be free from heteroscedasticity. Apply heteroscedasticity test, Bruch-Pagan-Godfrey. And the model should be free from arch effect. Apply heteroscedasticity test arch. Residual must be normally distributed. Apply Jacobra test. Ensure the model is stable. Apply COSM and COSM square graph. Now let us start with applying ARDL model in EViews 10. Before we starting using the model, of course, before we test the stationarity and follow these steps, as you can see it, before we test the stationarity, we have to go for lag structure criteria. Let me go to EViews, and this is the variable we have. As we said, we used lag, log GDP, log export, log import. We open it as here, as you can see it here, we open it as a group. This is the data, 3 variables, and here we have to test the lag criteria. How to test it? I'll go to quick estimate var. Here we have to type the variable log GDP, log export, log import. The data 1977, 2000, and the lag length between 1 and 2, press OK. Here the output for the lag length criteria, and from this output we have to go to look at the lowest AIC and SIC. So AIC is lowest, so we are going to test to find the lag on the according to the KICA information criteria, which is AIC. So I'll go to view lag structure, lag length criteria. Let me put 2. Okay, or 3 you can put. Here we can see that the lag we use in this model 2. So in this case, after we change the lag length, we go to step 2. Step 2, check your stationarity, unit root. If your series is, let me just put it here, which is step 1. We find the lag length. Step 2, check for stationarity, check for stationarity level, which is unit root. Okay, if your series of your series, then if the data stationary to fulfill the assumption of ARDL bond tests model. Or we move to, otherwise we move to another test. Okay, so now we have to check for augmented decay failure. If you can look at here, to test stationarity, look to, to augmented decay failure. Test for unit root. Test for unit root. So first we have to, let me just put it, first we test unit root at level okay with the three options, with intercept, and the trend, with none. So the same we are going to test for the first difference with the three options above. Okay, so let me go to EViews now and test one by one to see whether we go to EViews. Okay, now we'll go to quick to test the stationarity for the first variable, log GDP. Go to quick, see the statistic, unit root, log GDP. Click OK, and here we have to use augmented decay failure. As you can see, there is many options you can use, but in our case we use augmented decay failure to test for unit root or stationarity. First I test GDP, logarithm GDP at level with intercept. I leave the automatic selection SIC as it is, and maximum lag we can use 5, but let me put 2 here. Okay, press OK. You can see it, probability T statistic less than the critical value at 1, 5, 10%, or p value 55.87 greater than 5%. So we're still the variable not has a unit root. The same thing, we'll go again to view unit root, and then we use for intercept with trend, keep everything as it is. The same thing, T statistic less than the critical value, and p value this greater than 5%. The third thing, we go to take none with level, leave everything as it is, press OK. You can see the same thing. Now we have to check again. We'll go to view unit root. We use the same variable GDP at first difference with intercept, leave everything as it is, press OK. You can see here 3 is greater than 3 at 5%, or p-value less 2.5 less than 5%, which is significant, so the variable has no unit root, which is stationary. The second part with intercept, unit root with trend and intercept, leave everything as it is, click OK. You can see here there is 3, 2 less than, is not the variable stationary at and trend and intercept. The third one we have to use none and press OK. You can see it is stationary, so 2.77 greater than, which is significant, and 1% and 5% and 10%. So in this case we check the variable, then we'll go again to check the second variable. I'll go to quick, serious, and unit root. We have to use log export and click OK. So I'll go to level and then intercept, leave everything as it is, just here change it to lag 2 and then press OK. You can see it greater than 5% or t statistic less than critical value. Then I'll go for another test for trend and leave everything as it is, trend and intercept at level and then press OK. You can see it less than greater than 5%, or you can see for a week with 10%. Still we have a unit root, and the third thing we have to test it with none and then leave everything as it is, press OK, the same thing happened. So now to recover this problem we have to go to EViews again, unit root, and then move to first difference, start with intercept, leave everything as it is, because here automatic selection, click OK. You can see less than 5%, which is significant at 1%, significant at 5%, meaning that the variable log export stationary has no unit root. And then we have to go again to the trend and intercept, leave everything as it is, and then you can see there is stationarity and there is no trend, no unit root. Unit root, none, and press OK, the same thing. So here we have to go again to test for the other variable, which is import, log import, quick, serial statistic, unit root, log import, and then press OK. You can test it for level, intercept, 2 lag here, press OK, still suffering from unit root, the same thing. You can check for trend, leave everything as it is, and suffering again, still the variable log imports has a unit root, and then the third one with none, same thing. So we have to change to remove this problem. To make the variable stationary we have to go to first difference and intercept. We have to check in first difference with intercept, first difference with trend, first difference with none, and then we can see there is stationarity and the variable log import has no unit root. The same thing will go to trend, has no unit root, which is 3 less than 5%, the probability as you can see it here, or t statistic greater than t at 5%. And the third one is go to unit root, none, press OK. The same thing, we can see that we solve this problem for the unit root by using the difference. So after we use the difference here at level and at first difference for 3 option, unit root with the constant, trend and constant, and none. So after we test the unit root and we find that all the variables are stationary at first difference or mixture, for a few ones for stationary and a few ones and at level and few ones stationary at first difference, then we can move to apply ARDL bond test model. How? I'll go to quick estimate equation. What is our equation? Log GDP, log export, log import. Then I move here to ARDL model, autoregressive distributed lag model. And here we found that the lag 2. So I change it to lag 2. Sorry, lag 2. And then we change it from the trend specification to constant. Leave everything as it is. The year is 1977, 2000. Press OK. And this is the output. From this output, we can find whether there is a short run and long run a relationship between the variable by using EViews statistics. So I'll go to view, coefficient diagnostic, long run form and bond test. Here you can see this. This is the GDP log. You can see it. This is ECT, the error correction term. And this is here the long run coefficient. And here the EViews statistic comparing with both upper bound or lower bound. If EViews statistic greater than upper bound, it means there's a long run association between the variable. This is, we explained that before in other video in details. So now I'll go to check for coefficient diagnostic. I'll go to error correction. You can see con equation lag 1. This is the error correction, which is the ECT. We call it ECT, or error correction model term. And here, when we look at these, we can simply explain in different way. Now, let me just show you how these, the guideline or our plan. Our plan is if F statistic, as you can see it here, if F statistic greater than the upper bound, this means that we have the evidence to reject null hypothesis and accept the alternative hypothesis. This means that there is a configuration of or long run association between the variable, or all the variable they move together in the long run in the same direction. And the other hand, if statistic less than upper bound, meaning that we have the evidence to accept null hypothesis and reject the alternative. This means that there is no configuration or there is no long run association between the variable in the long run. Here we can see that the F statistic, as you can see, 8.17 greater than upper bound test. And this here, there is a configuration among all the variable, log GDP, log import, log export, and we can say there is long run association and short run between the variable, because here, as you can see it, here there's a short run or the speed of adjustment towards the long run association, and the speed of the adjustment, which is the whole model adjustment in the long run, which 84.02%, which is the speed of adjustment, because this is negative and significant. So now, after we test, just let me give some more explanation for the error correction term, which is this part here, the speed of adjustment, 84.02, negative and significant. Here, this must be negative, and must be, which is statistically significant. So we conclude there is a short-run association. This is the speed of adjustment towards the long-run associationship. It adjusts in the long run at the speed of 484.02%. Now, after we check that, here we have to explain the long run data, or as you can see it here in the previous one, long run, and this is the long run variable. We can look at it for one by one. First we'll go to log export. As you can see, the p-value is almost 0024, which is less than 5%. This means that export has a positive coefficient and is statistically significant, which means that the export explains the dependent variable log GDP, and here we have the evidence to reject null hypothesis. The second one is LIM, which is statistically significant, positive coefficient, and this means that the variable log import positively explain the dependent variable, which is here, the dependent variable log GDP, and this means that we have to reject null hypothesis and accept the alternative hypothesis. This is what we have to do with the short run equation and the long run equation, and the interpret of the coefficient in the long run. Now we have to move to test the diagnostic test and the data. As we mentioned before, the data must be free from autocorrelation or serial correlation problem, data must be free from heteroscedasticity problem, and data must be free from the arch effect, and the data or the residual must be normally distributed. Then the model must be stable. So I go and take one by one. First, I'll go to view, EView, residual diagnostic, serial correlation, leave it the lag 2 as we find in the lag criteria, press OK. Now R square, observed R square corresponding to chi-square p-value 93.84, which is greater than 5%. Of course, this is here, we have to test it at Proch-Godfrey serial correlation LM test. So the p-value here is greater than 5%. This means that we accept null hypothesis and reject the alternative, meaning that the model is free from serial correlation. The second thing we have to test for heteroscedasticity. Proch, Pagan, Godfrey. Press OK, and you can see this is the R square corresponding to chi-square probability 77.91, which is greater than 5%. This means that the model is free from heteroscedasticity, or the model is homoscedastic. The third one is to check for arch effect, and then you can see the observed R square corresponding to p-value of chi-square 73 point, meaning that the model is free from arch effect. And then we'll go to the residual for test the residual, whether the normally distributed or not, histogram, and you can see here the residual Jacabra 6.91% corresponding to p-value, which is, as you can see it here, 58.07, which is greater than 5%, meaning that the residual are normally distributed. So the final thing we have to test for the stability of the model. I'll go to view, stability diagnostic, regressive estimate, ordinary, only least square, then isolate COSM test. You can see the blue line lying between the two red lines, so the model is stable, because this is the blue line lying between the 5% significant level. Then I check for the COSM square. I go to the same thing, COSM square, and you can see the blue line between the two red line, which is significant. This is what we have to do with the ARDL model. Thank you.